So in this slide, we are talking about heat. And specifically, we're talking about the types of heat that are found in a subduction zone setting. If you guys remember from before, a subduction zone is an area where we have one slab that is being subducted or pulled under another slab. The heat that is responsible for metamorphism in this area is from the geothermal gradient. So the geothermal gradient is the idea that as we go deeper in the earth, we get hotter in temperature because we're getting closer to the mantle, and which is closer to the core. So we have this heat that's radiating out from the center of the earth. And as we get closer to the center, it gets hotter. Should make sense. An idealized geothermal gradient, that is one that doesn't have any influences from any types of tectonic movement, is about 300 degrees per kilometer, which you can see illustrated in the slide. Now, as we go towards a slab, you can see that that geothermal gradient is altered. And the reason is because we have this cold slab that's been at the surface of the earth for however many thousands, hundreds of thousands, millions of years, and it is now being subducted into the hot mantle. As it does that, it changes the path of the geothermal gradients because we have this cold slab going down that's essentially cooling the interior of the earth. As it goes down, it begins to melt. Once it melts, because it gets hot enough at the bottom, as it gets deeper into the mantle, that melted material rises up to the surface of the earth, and as it does that, you can see that the opposite effect takes place. Here we have the geothermal gradients rising because we have that very hot liquid magma that's rising up through the crust of the earth to become a volcano.